equation for displacement of in an SHM situation is the displacement x is equal to the maximum amplitude A cos of omega t. Now you probably know that omega equals 2 pi f. 2 pi f. Okay, so that's going to be very, very useful to us. Right, so what is the maximum displacement? Well, the maximum displacement is 10 centimeters, so that goes there. The cos goes here. Omega we know is 2 pi. F, what's the frequency? The frequency, right, we're told that the time period is 0.2. Time period is related to frequency by being 1 over f. So, and if you do the opposite of that, you get f equals 1 over the time period. So it's 1 over 0.2. So you get 1 over 0.2. The value you get there is 5. Okay, so that 5 will go here, 5. And the time period is whatever it is. So t. So if you notice, you've got 10 cos 2 pi times 5. Well, that's basically 10 pi. It'll be 10 cos 10 pi t, which, if you notice, is the answer just there. Okay, cool. Right, we've told the mass is 0.25. It has an amplitude of 0.8 centimeters. So we need to watch out for that. That might come to meters that at some point. Mass is correct. Frequency of 2 hertz. Right, we're being asked to work out the time period. So the time period is 1 over f, which is 1 over 2, which of course is a half. Right, calculate the displacement of the oscillator after this value here. Okay, so the displacement is given by the formula x equals a cos omega t, and we've discussed already that omega is 2 pi f, so that's going to be a equals cos 2 pi f t, and what we do is we stick in the values that we know. So we've got the maximum amplitude is 8, so that's going to be 8 centimeters there. Cos 2 pi frequency, well, we know that's going to be 10 pi. That's 10 pi. And the time is 0.125 times 0.125. Now, just remind you guys, all of this here is in a paragraph. Now, you need to make sure that you've got this in radians. This is being measured in radians. If we're going to be using pi here, it needs to be measured in radians. So when you plug in all the values of that, you'll find that displacement is actually 0 centimeters. So that is 0 centimeters goes in there. Okay. If we look at this one here, again, exactly the same technique. It's going to be 8 cos 10 pi multiplied by 0.25, and again, if you plug those in and have it in radians, your answer will come out as minus 8 centimeters. And if you do it for this one, exactly the same sort of values, you come up with the answer of 2.5 centimeters there. Calculate the maximum. Right, the equation we use to work out the velocity in simple harmonic motion is given by the amplitude multiplied by the angular velocity omega multiplied by sine of omega t. Omega, as we know, is equal to 2 pi f. So you substitute these values in there. V equals a 2 pi f sine 2 pi f t, close brackets. When you stick in the values, you've got, we want to do this in meters, so we need to change this into meters per second. we could leave it in centimeters potentially, but we'll put it in meters. So that'll be 0.08 times 2 times pi times 2 times sine of 2 pi f, which, well, is 2 pi times 2. We don't know what the time is, but what we should know is that when this value, the velocity, is going to have its biggest value when sine of whatever this is equals 1. When the sine of this equals 1, that is when the velocity is going to be the greatest. So we don't even have to work this out, to be honest. So what we can do is, I mean, you could work it out because you've got 2 hertz up here, and you'd know that roughly if it takes half a second to do a complete time period, you would know it's going to take roughly a quarter of a half, which is an eighth of a second, to get from here to the midpoint, which is where it's going to be going fastest. Okay, and it goes up to here, and it goes back to here, and it goes back to here, and that takes half a second. But anyway, we just know that this here, the velocity is going to be biggest when this equals 1. So let's make that equal 1. So now you get v equals 0.08 times 2 times pi times 2 times pi. Okay, and when you put that in, you get the answer of 1.00 something or other. So 1.0 is fine, meters per second. Right, calculate the maximum force acting on the oscillator. Okay, so we know that, if I do this up here again, we know that force equals mass times acceleration. Force equals mass times acceleration. The formula for the acceleration in simple harmonic motion is given by omega squared x. Okay, that's the general equation given for the accelerations. Sorry, for the accelerations, and we know that x, for example, we had a value earlier on that x equals a cos of omega t. So this is going to be quite a little bit complicated here. But actually, to us, we can leave it like this. We can leave it like this because I've just realised that the omega squared, well, that's going to be 2 pi f all squared. Okay, and you can multiply it by the x. Now, your biggest force is going to be when the pendulum is out away, or whatever it's doing SHM is furthest away from the equilibrium point. And we've been told that the distance it goes to is 8 centimeters, so it goes 8 centimeters out. So we know that's going to be 0.08. And when I put in my various values, my value of f we said was 2. So 2 times 2, that's going to be 4 pi. All this needs to be squared times 0.08. Which of course is going to give me 16 pi squared times 0.08, and that'll give me my acceleration, which I'll quickly work out now. Which comes in at 12.63 meters per second squared. Now I need to do, because it's force, it's F equals ma. The mass, we're told, is 0.25, 0.25 multiplied by a value of acceleration 12.63, and if I put that in there, I end up with the answer of 3.158, which we round up to 3.2 newtons. Cool. Okay, so at this point here, the potential energy is at maximum value, but it stops, it's got zero kinetic energy. And the same thing happens at the opposite end here. So they're the mirror image of each other. Potential energy maximum, kinetic energy is zero. In the middle, it's dropped at that height, so it loses its potential energy. In fact, its potential energy is at its minimum, or zero, and its kinetic energy is maximum. In order to work out the kinetic energy, the equation for kinetic energy is a half mv squared. Right, so we know what the mass is. We've been told the mass is 0.25. And then we need to know what the velocity is. Now, of course, we calculated the velocity in question C. And for question C, the answer came out as 1.01 meters per second. This needs to be changed into needs to be squared, of course, because it's velocity. And when you put this in your calculator now, you'll get the answer of 0.13. Okay, so the answer there is 0.13 joules, and that potential energy at that point is 0. There's the equation for displacement. Of course, the 2 pi f can actually be omega, so that sometimes gets written like that. So I'll write down here x equals a cos omega t. The velocity is given by minus a omega. This time it's the sine of omega t. And the acceleration is given by acceleration equals omega squared minus omega squared x. Okay, so you could theoretically put this equation into there to work it out. Well, of course, what you'd end up with then is you'd end up with 2 pi squared f squared, 2 pi f all squared and x would be a cos 2 pi f t. That would be your value for acceleration.